starting with number 22 from the paper test review for Unit 3. And number 22 states, if u equals 9i minus 2j and v equals negative 3i plus 7j, find the u vector minus vector v. Okay, so when we subtract vectors, we take the a components and subtract them, and then we add that to the b components, and then we subtract those as well. So what does this look like? This looks like 9 minus negative 3i plus the b component is negative 2 minus 7j. So 9 minus negative 3 will give me 12i minus 9j. So that is the resulting vector from subtracting those two. Now for number 23, it says if vector v equals 9i plus 12j, find the magnitude of v. To find the magnitude, we have to do a squared plus b squared and then take the square root of that. This is very, very similar to finding the Pythagorean theorem. So if we go here, we're going to do a, which is 9, and we're going to square it, and then we're going to take the b component, which is in front of j, which is 12, and square that. So when I do that, I get 81 plus 144, and when I add those together, it actually works out quite nice because I get 225 underneath the square root, and that is a perfect square, which results in 15. All right, so that brings us now to number 24. Okay, so let me go back there and look at it. So number 24 says find the dot product of v dot w. Okay, so v is given to us as 6i minus 3j, and w is given to us as 8i plus j. So the dot product says we take the a components and we multiply those together, plus we take the b components and multiply those together. All right, so a1 is 6 times a2 is 8, plus b1 is negative 3 times in front of j on that w vector is 1. So 6 times 8 is 48. 3 times 1 is 3, so negative 3. So 48 less 3 is going to give me 45. And that is the dot product of those two vectors. All right, number 25. Might as well keep on going here. 25 states that we have to find the angle between the two vectors. And we're finding that between v and w. Okay, so vector v equals 5i. I'm going to put 0j just to keep track of everything. And w equals just j. So I'm going to put 0i plus 1j. Okay, so I just rewrote them just so I could work with it. Now, if I have to find the angle between the two, I have to use a formula. And the formula is this: cosine theta equals v dot w over the magnitude of v times the magnitude of w. Okay, so let's first find v dot w. Let's work on that. So remember, I take the a components and I multiply those together, plus I multiply the b components together and I add those. So a1 is 5, a2 is 0, plus b1 is 0, and b2 is 1. Okay, this ends up being 0 plus 0, which equals 0. Okay, all right. By the way, if they're asking you, and this happens not in this problem, but another problem, if they're asking you to find if an angle is orthogonal, if your dot product is 0, that means that those two are orthogonal because cosine at 0 is pi over 2, which is 90 degrees, okay? So that's for later. But nonetheless, we did get 0 here. Okay, I'm going to continue on just to show you the process. So the magnitude of v. So remember, we take the a component, square it, plus the b component and square it, and take the square root of that. So the A component is 5, so 5 squared plus 0 squared. That equals the square root of 25, which is 5. That worked out nice. Now, W. If we take the magnitude of W, same thing, A component squared plus B component squared. So the A component is 0 squared plus the B component is 1 squared. So the square root of 1 equals 1. Okay, now I'm ready to put the pieces together. So cosine theta equals, now I found the dot product from up above, which was 0. The magnitude of V is 5 times the magnitude of W, which is 1. So cosine theta equals 0. If you want to solve for theta, you have to take the inverse cosine of that. So where does cosine equal 0 on the unit circle? It's pi over 2. Okay, so the angle between the two is pi over 2, which means those two angles are orthogonal. Okay, because they're 90 degrees away from each other. Okay, all right, that was number 25. I'm going to stop here and do 26 and 27 in another video. But thank you for watching 22 through 25.